Good morning. For a quick introduction, my name is Jeremy Martin. I'm a scum-sucking contractor. I've been in the field for a while. Again, primarily working with forensics, pen testing, and cyber warfare. But outside that, let's get going. So in this talk, we're going to be covering using CSI Linux to program two-way radios. We're going to be using chirp to program a Baofeng UV-5R. Just remember, we're going to be covering the good old FRS frequencies. Those pretty much can be used by anybody with regular radios. With that being said, the gqrx does require an FCC license, so keep that in mind. I'll mention that a few more times as a reminder. But chirp was added to CSI Linux along with several other applications dealing with SDRs, ham radio, and frequency monitoring. That can all be found under the SIGINT section within the menu at the top left-hand side. So at this point, let's go and get started. So right now I'm going to be talking about the Baofeng UV-5R. It's a two-way radio. It deals with the right around the 144 to 148 frequencies and the 420 to 450. It's a little bit more than that, but it's a really nice handset. It's very, very cheap. As you can see this right here, and I'm going to be putting the link on screen here in just a second, but it's about 22 bucks. Some of them you can get a little bit more, especially if you plan on doing getting the programmable cord, or basically program cable. With the program cable, you're able to connect it to your computer, share it within the virtual machine or within CSI Linux, and then program your two-way radio with chirp. So again, this one is pretty nice. It does talk on some of the frequencies that are outside of the FRS GMSR range, which means you're going to have to get a ham radio license to at least broadcast on those. But it can get frequencies such as NOAA, the weather frequencies, things in that area. So again, it's a definitely pretty decent radio. With that being said, it does give the capability of getting 128 channels pre-programmed, and those are the ones you can actually program with chirp. And it goes up to effectively 5 watts. So you can't communicate with that amount of power unless you have a ham radio license. Same thing with GRSM. You can't communicate on those frequencies without, again, a license within the FCC if you're in the US. You do need to know your specific rules and regulations in whatever country that you're in, but what we're going to be talking about is strictly US based. So with the GMRS license from FCC, you can broadcast up to 5 watts. Without that, you're pretty much stuck with the 2 watts, which is going to be low frequency on the chirps, or high frequency is going to be the 5 watts. So this right here, back in 2017, they did change things a little bit here in the US. So now a lot of the FRS and GMRS frequencies do overlap. Just be careful again. Sometimes you cannot communicate at like 50 watts unless you have a base station or a bigger system. With the two-way handsets, you're stuck at 2 and 5 watts. So in this instance, we're looking at channel 1. These are the common. So if you're looking at a basic band plan, this is actually a pretty good one. You're looking at 22 channels, channels 0 through 22. 1 being the call frequency. You can reach out to anybody with an earshot. You have your emergency frequency at 3 and 17. And at 20, you're looking at emergency and travel safety and assistance. So just keep these in mind. This file is actually in the documents folder called FRS-GMRS frequencies.pdf. So you definitely have this available to you anytime you need to use it. So right now what we're going to do is we're going to open up chirps. So if you go to the CSI Linux menu, go down to SIGINT, and then hardware programming, go and click on your chirps, program your radio icon, and here in a minute, that's going to pop up chirps, and then give you basically a warning, things in that area. So the warning usually comes up when you're trying to communicate with your radio. So what we're going to do is make a backup. So right now I do have one of the Baofeng UV-5R radios in my hand. I'm going to go to radio, download from radio. I have this radio connected to one of the program cables. So I'm going to see some red flashing on the indicator light. So I go to download. Make sure that what you have in devices is USB, and in my instance it's the FTD FT232R USB UART. This is going to be the program cable. Again, just a simple USB device that the cable connects to the basically the mic and the earpiece headset imports within the radio itself. So once these two are checked, these are going to be shared within the virtual machine. If you're using the bootable Linux system or the bootable Linux CSI triage drive, then you don't need to do this. It's going to be one of these other TTYs. So here, the shared is going to be the USB at the very bottom, /dev/TTY USB 0. Make sure to click on that. We're choosing Baofeng out of a list. And then the model, UV-5R. So again, this is a great cheap handset. It's good for emergencies. I know it's definitely popular in the preppers world because it's kind of a throwaway radio. For 23 bucks, sometimes you're getting a little bit more expensive, especially if you're wanting an extra battery and also the program cable. It might be 30-40 US, but again, very, very inexpensive. Going to go in and hit OK. Now it's telling me to turn off the radio. So I need to pick a frequency that is not being used by anybody else. So I'm doing this in the background. I'm going to connect the cable to the mic speaker connector. Make sure the connector is firmly connected, and it is. Turn the radio on. I'm turning it to 100 volume, or all the way, just to make sure there's a good connection. Because over this cable, it's actually analog. So it's going to be communicating over, again, speaker mic. Think of that as read-write or receive-transmit frequencies. Ensure the radio is tuned to channel no activity. Click OK. So once I hit OK, it's now cloning the phone or cloning the handset. I'm seeing an indicator light of red on both of the handset and the program cable. That traditionally means it's going to be reading from the device. Right now it says cloning. So that's good. Right now I have a few frequencies already in here. So I'm going to go to File and Save As. So this will allow me to save an image file of the device I already have. I'm overwriting one because I went through this process before, just double check and make sure everything worked. But I just made a backup of these channels, 0, 1, 2, and 3, 22, and 31 through 38. So if I needed to go back, I can absolutely open that file, open recent, or just open period. This is the image. And then upload to radio. So when I do that, it already has the program cable built in. So it's the dev TTY USB 0, Baofeng UV-5R, hit OK. And now when I do that, it is reprogramming the device. So now we see green indicator light blinking on the handset, and both are red and green on the program cable. Once it's done, it's actually going to reset the handset. So the Baofeng is going to reboot real quick. It says welcome, and now it has the good old channel frequency. I can go through and see all the frequencies that are currently in the device. So I'm going to close all these. I'm going to start from scratch. Now I want to manually input some of these frequencies. SIGINT, hardware programming, chirp. It's already set up for the device itself. So radio, download. This is always a good idea to go through the process, as this is going to set up a baseline. And also backup what you already had, in case that if you mess up, you can always go back to what you had previously. Okay, device is booting up. Welcome. Now it's already up and going. So what I'm going to do is delete everything. So this is going to take a minute, but this is going through all of the channels and wiping everything out. I want to start from scratch. I want to pre-build certain things, and these things are going to be the channels that are already in there, frequencies that are already in there, and I'm going to put my own in there. So once this is done, looks like it just finished. Just double checking, going all the way down to channels 127. So again, there's 128 channels. Starts at channel 0 all the way to channel 127, 128. So this is a clean slate. We're starting fresh. So at this point, what I want to do is start adding some of these in here manually. So I'm going to copy. This is going to be an FRS or GMRS. So again, FRS is 2 watt, GMRS is 5 watt. So if we go into chirps, double click on one, put in the frequency that you want to look at. Under mode, I want to do NFM, because that's part of the FRS range. Because it's high right now, it's actually going GMRS. If we do low, it's going to do FRS. So if you're not a ham radio operator or licensed ham radio, pick low. If you're licensed with GMRS, you can pick high. If you're ham radio, pick high as well. We'll do the same thing with number 2 or channel 2. NFR or NFM. We're going to do the emergency channel here. So these are just transmit and receive frequencies. If you're interested in other things such as using repeaters, which drastically increases your range, we do talk about that in some of our other material or courses, things in that aspect. But when it comes down to it, the biggest thing what you need to understand is if you're not licensed, you need to stay on the frequencies that you have authorization for. So whatever country you're in, use those frequencies. In the US, the FRS, that's a go-to. Unless, again, you're licensed for GMRS or you're licensed for ham. The handset that we have, the Baofeng UV-5R, allows you to speak on a lot more. So again, you have transmit and receive. Never transmit on a signal that you do not have authorization for. Receiving, that's another issue. You can receive essentially any frequency that you're allowed to, which is most of them. Like NOAA, things in that area, which we're going to talk about here in a bit. But biggest thing here is right now we have channel 1, channel 2, channel 3. we can both transmit and receive on these because they're on low. Again, if you're authorized, you can double click on this and go to high. But we're going to stick with low for everybody else's sake. So at this point, we can go to radio and upload a radio. This already has our information in, our program cable, our handset. Go and left click on OK. Make sure turn off radio, connect to cable, make sure it's good and connected. It's on a station that's not receiving anything else, and then hit OK. If it's on a station that's kind of talky, or a lot of stuff's going through it, it's going to interfere with the upload and download. So you're probably going to get errors. If not, you're going to get garbage content. So here it's cloning, it's uploading, and we're going to go and do a quick check on this device. It just rebooted. I'm in channel mode. I'm going to go and unplug the cable so everybody can hear.
Frequency mode. Channel mode.
I have channel 1, channel 2, and channel 3. Channel 3 is 46612. Channel 2 is 46587. Channel 1 is 46562. Now we're going to plug the cable back in. So the cool part about Chirp is it does have some extra capabilities. So, if you go to radio, go to import data from source, we have several options. So for repeaters, you need to make sure you're authorized to communicate on a repeater. Repeaters sometimes have 2 channels. They allow you to bounce off a tower and communicate further within the environment. So in this instance, we're going to go to each one. Let's do DMR mark repeaters. It's going to ask you what city and state you are. Denver. And see what we can pick up at a range. So you need to spell out the place you're at. Import radio reference. This usually requires a username and password, which we'll get here in a little bit later. And we also have repeater book, political and proximity, what location you're at versus, again, very similar. So I'll just do political. We have Colorado, Weld County, band all. The reason why I do all is because Chirp's actually a pretty smart application when it tries to identify what frequencies the handset has access to. You're going to hit OK. So anything in gray it does not have access to based off the bandwidth or the frequency. Ones in black it does. So what I will do real quick is, let's do auto. We have 0, 1, 2, 3, 4, 5, 6. Now I'm going to do up a few. So I'm going to start off at 30. So auto baselined everything. So all these frequencies that it's allowed, which is 146.85, 147, 447, 200, 4473, 447, 475, and so forth. When I hit auto, it did everything to 0. And then when I went to plus 10, plus 10, plus 10, it now starts at 30. I said OK. So when I scroll down a little bit, we now see all those frequencies that are now set within the system. So this is not saved yet. It's not uploaded. but it's within the application to save it and to upload later. We'll do radio, import. Let's do this one. Again, it's trying to find application, so it knows what systems to give to you. In our Finder, again, have to log in too. So there is a really good resource if you go to radio, import, and radio frequency. I'm going to pick radiofrequency.com US. It is asking for a username, password, and zip code. So at this point, you would then essentially put in your information, set up an account, and then go from there. So just as a reminder, down here we have some repeaters. Just be careful about communicating with repeaters because you do need to either have a license or just be authorized to bounce off those. But what a repeater does is it gives you a lot more range when trying to communicate on your radios. So now what we're going to do, let's go back up here. So let's say if you want to move these, you can highlight them, just move down, and just keep doing that until you get right range. But what I'm going to do is add a few more frequencies. Let's start at 10, just to make things a little bit easier. I'm going to go to, or actually, let's do 4. Let's go to radio, import from stock config. Now we're going to do our FRSM and GMRS channels. Let's do channels 1 through 10. Just to make life a little bit easier, because we're going to add some NOAA channels here in a minute. So I'm unchecking all these wonderful frequencies. And again, just as a reminder, you cannot legally transmit on anything you're not authorized to transmit on. So here I'm going to get OK. Now I have channels 1 through 10. So now I'm going to go to radio, import channels from stock. Let's add some NOAA. Here, because we're starting off at 11, we're going to go plus 10. And automatically we see 11 through 20. Going to hit OK. And now we have these frequencies starting at 11 all the way through 20. These are going to be the weather stations here in the US. So now we have a good list, 1 through 20, and 35 through 42. These are going to be repeaters. Do one more, import from channel, and let's do marine channels for boats. So here, we'll do none. We're going to pick a couple. Let's start off at 21, 22, 23, 24. So 4 channels for aquatic or sea, marine. Hit OK. And now we have all these set for the ham radio. So now what we can do is File, Save As. Saving as a file update, and now we're going to radio, then upload to radio. Like we mentioned before, just going to hit OK, because it already has a radio brand or vendor and model. We're going to now see some green flashing on both the handset and red and green flashing on the program cable. And it's going to update all those channels to our handset, and then reboot the handset. Give just a second. Almost done cloning. There we go. As far as the handset, looks like it's rebooting now. It says welcome. And here we go. So now I'm going to disconnect again real quick. Turn on the volume. Go into channel mode.
Channel mode.
So right now I'm on channel 5. Channel 5 is 462. 662. So looks like everything updated just fine. So going back to what we said before, we just walked the whole process of manually updating individual frequencies, and then also going through the radio. Import from data sources. Some of these are going to be repeaters. However, here, import from stock config. These are going to be some common radio frequencies that generally around the world. So we're going to cover SDRs and gqrx. So ScienceDirect.com defines software-defined radios, or SDR systems, as a radio communication system which uses software for the modulation and demodulation of radio signals. gqrx is an open-source software-defined radio receiver. So now let's test the radio. You can easily test it with another handset, but I did want to cover some SDR in this as well, just a little bit. We're going to be using an RTL SDR. This is going to be using the RTL 2832U driver. And this one, relatively cheap. This is going to be a receive-only device, so this one cannot transmit. If you did want to transmit, you can use something like the Hack RF. The Hack RF is a half duplex, which means it can only transmit or receive. It cannot do both at the same time, but it's still a great device for pretty much anything you need. If you want something a little bit better, you can actually use something like the Blade RF. You have, Lime SDR. And if you want an even better SDR, you can use one from other places. For example, there's a pretty good organization called Edis, and they sell some pretty high-quality SDRs, or commercial-grade SDRs. But the price gets a little bit up there. It all depends on what you want to do. So in this instance, I already have it plugged in. So if you go to Devices, USB, just make sure that it's being seen on the system again. And of course down here, just make sure that that's still checked. So now, because in Devices we do see the RTU, or the RTL device, I'm going to go ahead and go to up to Linux menu, and then down to SIGINT. So once you go to SIGINT, go to SDR software, and we're going to be using gqrx SDR. These cheaper devices they're not as sensitive as some of the better devices, or the more expensive ones. So there could be a possibility that we might not be able to get the good signal. We might have to play around with the offset over here. But the frequency that I did want to play with, this is going to be in the 462 range. So it's going to be 462, 562. So here we're just going to test it, make sure everything's good. So whether FM, that's good. So let's just see if we can actually see, just make sure that the card's still there. Card's good. The 0001 driver. Hit OK. And then go into play. So now this is listening for communications. So I'm going to hit the quick talk button, see if anything goes. Does look like it does. But what we're seeing here is probably in this range. This is probably where we're actually communicating. So we'll go ahead and give a quick test. This is a test. Okay, did not go through. Let's try again the 462, 562. Gonna press talk again. So we see a spike a little bit to the left-hand side. So we're actually going to move this over just a touch. And then see if we can... Let's try it one more time. Testing. Okay, so if you see on the left-hand side, there's a little bit variation, a little bit further to the left. So we'll try it one more time again. Testing. Testing. Testing, 1, 2, 3, testing. So we still see the spike right here. So even though this is not the 562, we're going to see if this works. Okay, so that looks like we did get the right frequency. I'm going to step away for just a second, and then we're going to try the audio again. This is a test. 1, 2, 3. This is a test. Okay, so that does show that we were able to hear the radio. If we play around with the speakers a little bit, make it a little bit more clear, with the squelch, by default it's negative 150. I did pop it down to just 50 to make it a little bit easier on the audio on this video or on this presentation session. But all in all, we are able to see the handset, and it is working good. Now let's take a look at some FM radio stations with gqrx. So right now, I'm going to go to one that's in the geographic area. So I'm going to do 104.7. And so we can actually hear it pretty well. We need to move the antenna a little bit. But outside that, it does come in pretty good. Granted, what's playing right now is kind of weird. Sounds like a lot of yelling, but still, gqrx is good to go. Now let's take a look at another tool that we've added. So we go to Menu, SIGINT, SDR Software Defined Radio. We're going to go to the basic FM radio. So this radio only really supports the RTLs, so the RTL 28, 38, and 32 series SDRs. So just to test it, looks like the virtual machine does have it pass through. Going to go and power on, and then hit play. Okay, we did hear some static, so now I'm going to go and scan for it. So it looks like it did find a radio station. I'll go back, I'll unmute it real quick and try to tune back in. Under him, his chest landed on. And you can tell you're getting signal or good signal because this little section right here, it is showing that there's signal. So I'm going to go ahead and play. Now we're going to record a little bit of it.
Right now to overturn it. Well, a lot of the cars are starting up in the parking lot right now. A lot of these Chiefs fans have headed for the exits, leaving a swath of blue.
Okay, just stopped recording. And then if we go into settings, this will tell us where recordings are actually getting stored at. So here we should have under home CSI /music. Let's go and cancel out here. We'll go into the home folder. Go down to music. And we should see that last recording. Let's go and double left click on it.
Starting up in the parking lot right now. A lot of these Chiefs fans have...
So we were able to capture that. So relatively simple application. Again, it does require certain types of RTLs. It does not really work with the hack RF, at least the one I've seen so far, the Blade RF, but it does work with some of the cheaper RTLs. ADS-B, or Automatic Dependent Surveillance Broadcast, is a satellite-based surveillance system. The parameters that you'll see will be position, velocity, and identification, and this is going to be seen on the 1090 MHz range. Dump 1090 is an ADS-B demodulator and a decoder that will receive the transmissions and decode the aircraft transponder messages, either through SDR or through network connections. This one is going to be the Dump 1090. So Go to the dump, 1090 in the op folder. And because I'm lazy, I already typed this out a little bit. So if we do dump 1090-interactive-net, what that's going to do is open up a web server. And within that web server, it ties into the essentially Google Maps, so we can see the planes as they're flying. But also interactive, it's going to show anything that it sees flying through the air. So it looks like it's already identified two planes. We're going to wait just a little bit for it to propagate some more data. While we're doing this, I'll go and open up the browser. I'll move this to the bottom right so you get see it a little bit better. Then here, we're going to go to 8080, which is the default server for it, or default port. And we already see a couple airplanes. Let's go ahead and move this in a little bit closer. So we see one right here, and then one at the top right. So essentially you can let this run a while. The file does get relatively large. However, you can use the RTL_scan file to create a dump file and then basically pipe it to the page and just watch historical flights. But outside that, relatively simple. Again, run the application. Just make sure RTLs or SDRs plugged into your virtual machine. Again, we go up to devices, USB. Once it sees this, then it just starts capturing the beacons. Again, good old flight tracker. So now let's capture some and put it to a file so we can look at it here in a little bit. So the syntax for that's going to be RTL_SDR-F, and that's going to be the frequency. That's going to be the 1090. And then here, this is essentially going to be the gain. Gain's 50. We're dumping it to a file called output.bin. So as soon as I hit enter on this, it's going to start capturing the content, set it up. And this file is going to be essentially sitting here for a bit, so I'm going to go ahead and pause the video, and we'll start back here in just a minute. So now after we've run the RTL_SDR, we're going to run the dump 1090 again, but put the --i file in the file we just created, which is output.bin with a --net. That's going to allow us to look at the content as it's being replayed. So we'll try to get back to where we were before. Now we're seeing planes being created and added. It's hard to see, but they're moving a little bit. Some are being added, some are being removed. But this is a replay of what we were able to capture with just the basic cheap SDR. Make this a little bit bigger. We saw a couple planes from states away. We do see them moving. Sometimes they do disappear. So that means they're a little bit out of range, didn't get the signal at that time. But right now we have 18 planes. Here's another, bottom right hand side. It's going northeast. And then one going to the west. On the right hand side, we can actually see it going through that file that we were able to capture all that content through. We did run this for probably about 45 minutes. So we do have a little bit more than we're originally planning, but we do see a lot of content going back and forth. But all in all, that is 1090 dump in a nutshell. And we'll go and stop this. And then go from there. So now we're going to cover a tool called qflipper. qflipper is a graphical desktop application for updating the Flipper 0 firmware. Flipper 0 is a portable multi-tool for pen testers. So essentially it will allow you to copy and rebroadcast signals. So now we're going to take a quick look at the Flipper Zero. So we've actually added within the SIGINT hardware programming the qflipper application. This is the application that can be run on a PC or computer. There's also a secondary application that can also be run on Android devices as well. So effectively it gives you some of the same capabilities. So right now we're going to go ahead and run it. I do have my Flipper Zero plugged in. I'll go and cancel for now on this one. So since it is plugged in, now I need to plug it in through the virtual machine. So go to USB, Flipper devices, and now we see the Flipper. So if there were some updates on the Flipper Zero site, it would allow me to update it right then and there, which is good. It's also telling us what the device is, so if we did need to communicate it through some other means or mechanisms, it's the TTY ACM0. Of course, we have the firmware date, we have settings information on what kind of updates that we want to look at. Right now, we're just looking at the release. You can have release candidates. This is kind of like beta testing, some potential bugs, and development's probably going to have a few more bugs. Then we also have the ability to back up and restore these. So it's always a good idea to back up whatever the firmware is, especially if you do plan on updating anytime soon. So I'm just going to do -1, making it easier to memorize. So here, you want to pick a directory. Okay, so choose that directory, choose, and now it should be backed up. So it's going to take just a minute. Hit continue. So now we have basically a backup file if we do need to restore it. Then of course these are the files on the device. So for example, with SD card, we do have some in infrared already. So made a couple copies of some remotes. But all the content that you're looking at that you've been able to essentially record is going to be stored in little files that the Flipper can use. So with that being said, I'm going to go back to here. Let's go and double left click on the screen for Flipper. Now it's giving us access to essentially remote control the device. With the Android application, it's working on Bluetooth, so you can have a little bit bigger distance to play with. This does require, again, the USB-C. You might be able to, again, hack around that through other mechanisms. But let's say if you have a 6-foot USB-C cable, then you can put that closer to the devices that you want to control or copy. So right now I'm going to go into the right side. That's going to give me my passport. Go back, click on the center button, and then that's going to give you access to all of the items that are inside the capabilities. So for example, if you wanted to copy HIDs, you have the 125K NFC, same basics. So the nice part about this is this does give you some capability, especially if this physical pad on the Flipper Zero does get damaged. You can still, again, control the device. But outside that, in a nutshell, you can now control Flipper Zero. Now to summarize what we've covered, 4 main sections. We covered chirp and configuring Baofeng radio within CSI Linux, gqrx, and being able to listen with an RTL SDR, transmissions with the handset, and then also transmissions from fmradio. Also covered dump 1090 to track some of the aircraft in the general area, and the qflipper Zero, which allows you to essentially not only update the firmware of the Flipper Zero, but also remotely control it. All that content is pre-built into the newest version of CSI Linux. If you have any comments, suggestions, or questions, feel free to email support@csilinux.com.